Hi and Assalamualaikum. We are from Group D, BMMA. S2 Sokwan will present our assignment for BMMA 3533 Vehicle Dynamic on the topic of vehicle tires. So, let's move on to the next slide, which is the literature summary. As you can see in the table, it listed 5 different academic research papers that have been reviewed by every single member of our group. So it's a total of 5 research papers, and for the next part, each of our group member will share their finding on the review research paper. So we move on to the first person.
For the journal I obtained title Brake and Tire Particle Measure from On-Road Vehicle Effects of Vehicle Mass and Braking Intensity. The journal from Elsevier, month on year published is July 2021. Okay, for the methodology of this journal is aerodynamic particle sizer TSI APS 3321 and DT TSI dust track 8532 sampling. Okay, the brake and tire particles were sampled from the right front wheel of the test vehicle. 3 sampling inlets were installed near the brake and tire of the right front wheel as well as on the roof of the test vehicle for ambient PM particulate matter measurement. A custom-made apparatus was used which provides sufficient space between the sampling probe and the wheel under both straight and cornering driving condition. The brake sampling probe was located 5 cm from the center of the wheel, while the tire sampling inlet was installed 2.5 cm from the top of the wheel. The brake and tire inlet were installed 13 cm apart from each other. A full-size US SUV 2016 Chevrolet Suburban, a mid-size sedan 2016 Honda Accord, and a compact sedan 2017 Nissan Sentra were tested on a road. Okay, for the result obtained from this journal is effect of driving condition and vehicle mass on brake and tire emission. One of the goals of this work was to study the effect of braking intensity on brake and tire particle. As shown, for each vehicle, higher brake and tire PM 2.5 and PM 10 concentration are observed during more intense braking event. For both the brake and tire particle, higher particulate matter concentration are generated from the heavier vehicle during braking. This is more noticeable for the Chevrolet Suburban, presumably because its mass is approximately twice as heavy as that of the Nissan Sentra and approximately 60% heavier than of the Honda Accord.
Assalamualaikum and hi everyone. My name is Akalil Ahmad bin Dzulkifli and I will continue to my academic paper summary, which is the effect of motorcycle tire rolling resistance coefficient on the saving of fuel consumption. So the methodology is the rolling resistance coefficient RRC testing. In this test, 61 different models of tires were chosen to conduct the test. The RCC value of these motorcycle tires is determined through testing ISO 18164-2005. 5 motorcycle tires with RCC values ranging from low to high were chosen. The table 1 the RCC value, following with the figure 1 the surface, and after that the tire was fitted on the motorcycle and a chassis dynamometer test was performed, as shown in the figure 2 on the right. So the test speed was set to 50 km per hour and the test load was set to 65 kg according to the standard. The motorcycle was put to the test for 60 minutes, after which we measure the fuel consumption and distance travel. So the result is each tire was tested 5 times, with the result reported in Table 2. The results of the test revealed that the varying rolling resistance coefficients RRC had an impact on motorcycle fuel consumption. It was discovered that when the tire's rolling resistance coefficient was higher, the motorcycle could travel a shorter distance. In other words, a tire with a higher rolling resistance coefficient will use more fuel. According to the test results, the relationship between fuel consumption and rolling resistance coefficient is relatively linear, as illustrated in Figure 3. The fuel consumption will increase 1% with a 10% increase in rolling resistance coefficient. That's all from me, and we move on to AMSYAR QAYYUM. Thank you.
Assalamualaikum and good day. I am Shakurin Badrul HISHAM. My student ID B0919101191. My part is about dynamic tire friction models for vehicle control system. So for the methodology, one is the tire friction model. Model of dynamic friction describes the tire road interaction. The models have the advantage which developed from the first principle and based on simple contact control dynamic friction models. Physical significance are included in the parameters to tune the model. The models are speed dependent and parameters explain the road surface characteristic. Diagram 1 shows the static friction model and diagram 2 shows the dynamic friction model. Both models are slightly different. And number 2, the vehicle traction control. The experiment being done with considering one wheel model with the tire road friction. By using steady-state force friction point of view, the friction force is given as an algebraic function in static function of the slip coefficient. The friction force versus slip coefficient curves guide a simple way to achieve maximum traction between the road and the wheel tire. So diagram C there shows one wheel system with lump friction on the left side, and then one more is the distributed friction on the right side. So next we move on to the results of the academic paper. 2 types of friction model are obtained from the experiment. The static and dynamic condition are the conditions involved during conducting the experiment. Distributed models will be assumed the contact area patch between the tire and the road surface. The distributed dynamic model contact patch area is a series of elements and includes second order rate independent models. So this is table 1. Plot data for distributed Lou-Grey model, and then there are 2 types of distributed Lou-Grey model. For the static distributed Lou-Grey model friction model, and then diagram 5 dynamic distributed Lou-Grey friction model. So for static one, the torque is stable during 0 Newton meter, and then the friction force stable during about 3500 Newton, and then the slip coefficient is stable during 0.2. And then for the dynamic part is the torque is stable during 0 Newton meter, and then the friction force is stable during about 4000 Newton, and then the slip coefficient is stable during also about 0.2. So that's all for the dynamic tire friction models for vehicle control system of my part, and that's we move on to another part of our group members. Thank you.
Hi and Assalamualaikum. My name is Muhammad AZIM bin Muhammad SUHAIMY, and today I want to share one of the academic research paper that I have reviewed, which is tire slip angle estimation based on intelligent tire technology. So as for summary of the research paper, the researcher want to estimate the slip angle of the tire by using 5 different machine learning algorithm, which I will talk later. So for the methodology, the researcher used 2 sensors for this study. The first sensor with 3 axial acceleration sensor, and the second sensor with slip ring device. So the 3 axial acceleration sensor able to measure the acceleration in longitudinal, lateral and vertical direction. So but for this study, the researcher want only the acceleration in longitudinal directions only. For the slip ring device, it able to transmit the sensor signals from the rotating tire to NI DAQ system through the signal regulator. So for the second methodology, this is the machine that they use for this research, which is MTS flat track system. So for this MTS flat track system, the researcher able to insert the required vertical load and driving torque, speed and tire slip angle that can be applied to simulate the tire working under different conditions. Next, we move on to the result. So for the result part, the researcher want to display their result, their achievement in 3 different subcategory. The first one is traditional physical method. The second one, different learning machine method in frequency domain, and the third one, different learning machine method in time domain. So for the traditional physical method, which is by calculation mathematical method by the researcher itself, it can conclude that the estimated slip angle within 4 degrees are basically accurate. However, large error appears when the slip angle exceeds 4 degrees. This happens because the huge notch in large slip angle result in the unstable shape of the lateral deformation curve and large error in the calculated slope. Second part, which is by different learning machine method in frequency domain. So they compare how to able to obtain the slip angle by using 5 different algorithm, learning machine algorithm, which is NN based on output algorithm, and then random forest algorithm, recurrent neural network algorithm, support vector meshing algorithm, and gradient boosting method algorithm. So for the frequency domain, they can see an obvious result exists at large slip angle at RF, SVM, GBM. So however, for the frequency domain, the RNN algorithm shows a good capability of entire slip angle estimation similar to NM based output algorithm. So for the time domain, they conclude that the GBM and RNN algorithm able to give more accurate result in time domain since they have more complex structure, thus giving better performance when compared to other algorithm. So as a conclusion, the researcher agree that the RNN algorithm and NN based on output algorithm is the best to use to determine the tire slip angle for the real life situation. That's all for me. Thank you.
Assalamualaikum and good morning. Today I will explain about tire construction. So commonly in tire construction we have 2 types. The first one is common cross ply and the second one is radial ply tire. So today I will explain further more about this type. So basically the cross ply tire is the older form. It is also called a bias ply or conventional tire. It is construct of 2 or more plies or layer of textile casing cord positioned diagonally from bed to bed. The rubber in case cord run at angle of between 30 and 38 degrees to the center line, with each cord wrapped around the bed. A lattice crisscross structure is formed with alternate layer crossing over each other and laid with the cord angle in opposite direction. This provides a strong, stable casing with relative stiff side wall. However, during cornering, stiff side wall can distort the tread and partially lifting it off the road surface. This reduces the friction between the road and the tire. Stiff sidewall can also make tire run at high temperature. This is because as the tire rotates, the cord in the plies flag over each other, causing friction and heat. A tire that overheat can wear prematurely. So the second one, as you know, the radial ply tire have much more flexible sidewall due to their construction. They use 2 or more layers of casing plies with the cord loops running radially from bed to bed. The sidewall are more flexible because the casing cord do not cross over each other. However, a bed of 2 or more bracing layer must be placed under the tread. The cord of the bracing layer may be of fabric or of steel and are placed at 12 to 50 degrees to the circumference line. This form triangles where the back cord crossing over the radial cord. The stiff bracing layer link the cord loops together to give fore and aft stability when accelerating or braking, and is prevent any movement of the cord during cornering. The cord plies flex and deform only in the area above the road contact patch. There are no heavy plies to distort, and flexing of the thin casing generate little heat, which is easily dispersed. A radial ply tire run cooler than a comparable cross ply tire, and this is increase the tread life. A radial tire has less rolling resistance as it's moved over the road surface. Okay, that's all for today. Thank you.
Next, we move to the conclusion part. As we already know, tires play an important part for our vehicle, especially during acceleration and braking on the road. Other than that, tires also play major roles in the vehicle dynamic as to determine certain variables such as the slip angle, braking distance, and traction force on the road. Most of the academic papers that have been reviewed by our group members are all about the traction of tires to the surface of the road. There are many variables or factors that can determine the efficiency of tire tractive force during acceleration, braking, and even cornering situation. So, as a final advice, it is important to check the condition of our tire as to determine its condition and longevity for our comfort and safety purposes. That's all from our group. Thank you.